Yeah. So yesterday I have given a brief introduction about what are the parametric softwares, what is the non-parametric softwares and all. And today we will be moving to a 3D part modeling. Okay, and we are using a software called as Autodesk Inventor Professional. Okay, so in today's video, in today's session, we will be undergoing and complete part modeling as well as assembly drawing of a screw jack model. Okay, so I want everyone to open your inventor software. Okay, so you can find a shortcut, on the desktop. Okay, or else if it is not available, means you can go to start. Okay, you will get a Autodesk Inventor Professional. Okay, so just open it. It will take some time, okay, to get load. Since the software is a very vast software, it takes some amount of time. Okay, so this is your default screen. Okay, this is the default screen. So as soon as you open the software, okay, you will get a default screen like this. Okay, so first, before starting anything, I need to create a project file. Okay, so before starting anything, I need to create a project file. So first I need to create my project. So I will be doing many parts under one project called as screw jack. Since today's assembly drawing is on screw jack, so in screw jack, so if you just see in the manual, okay, so if you go to the page number 51, okay, so you can see a 2D drafting of the complete part modeling of your screw jacks. It consists of all the dimensions section of every individual parts of screw jack as well as the bill of material. Yes, okay, so here, and I want everyone to open that page. Okay, yeah, so today I will be doing the complete assembly on screw jack. So I need to create a project named as screw jack. So what is the procedure? First, go to projects. Here you can see a project. I hope everyone has created a folder named screw jack. Yes, okay, so go to projects. Okay, so you will get a screen like this, a dialog box, project dialog box. So here I need to create a new project. So click on new. Okay, so it is asking what type of projects are you creating. Okay, so either you can go for world project or you can go for single user project. Now we will be working on single user projects. We'll select that new single user project. So by default it is taken there, so I'll just go for next. Okay, so here it asks for what is the name of the project. So enter the name of the project as screw jack. Okay, just type the name as screw jack. Okay, now it is asking you to the workspace folder, okay, or the workspace directory where you want all your files need to be saved, right? So just click on that browse button there, click on that browse button. Okay, browse it to your folder where you have created a folder named screw jack, right? So I think everyone has created a folder in new volume. So there you have created in your respective USN numbers. So go to the assembly drawing, so then select screw jack. Okay, so click on OK. Okay, so your extension will be shown here, the directory will be shown there. So it is in E drive with your respective USN number folder. Inside assembly folder, inside again assembly folder, you have created a screw jack folder. So now click finish. Okay, so now you can see the project named as screw jack. Okay, please maintain some silence. Okay, yeah, so now just click on done. See that always when you are working on any files or working on any part model, that respective part model should be opened in that respective projects. Okay, so if you are working on plumber block and if you are opened the project in screw jack, means the part of plumber block will be getting saved in screw jack. So when you open it in screw jack, you will be not finding that plumber block folder, or if you open it in plumber block, it will be not getting open, it will be getting overlapped over another part model of a screw jack, because you have saved the complete model of it in the screw jack project. Okay, so whenever you are working on one single part of that project, you need to open that respective project. Done. Okay, so now just click on done. Okay, so now I have created the project. Okay, so next part is we need to start modeling the part models. Okay, so next is start doing creating the parts, 3D parts. Okay, so how to do that? So you can see a new icon there, click on new. Okay, so by default it will give you a new, creating a new files. Okay, so you have different formats are there. Okay, different format of different extendable files are there. Okay, so based on the standards you can go for English, you can go for metrics, you can go for mold designs, and if your system is installed with some more versions, you can see that in your old version. Okay, so so normally we will be working in millimeters, that is our metric. So choose metric here. As soon as you click on metrics, so compared to the previous formats, you have more amount of formats in metric, right? So here just remember, whenever you are creating a part model, the extensible file is .ipt. Okay, .ipt for parts. For assembly, .iam. Okay, got it? So for your 2D drawing, it will be .dwt. That you know. You have worked under AutoCAD, that you know that. Yes. So here you can create a 3D model, right? You can create or you can assemble all that 3D model into one assembly part. You can convert that assembly, 3D assembly to 2D. You can do the sections. Okay, so what you did in your orthographic, converting from 3D to 2D, you can directly do here by using some of the tools. No need to analyze it and write it. Everything is done by the software itself. And also you can give for some exploded views. I think, have you seen an advertisement of watch, right? So what happens is, while advertising they give an exploded view, right? So belt will be getting exploded, right? The lid will be getting exploded, every gears will be getting exploded. So that type of exploded assembly view, you can see that. And also you can create your own animation if you want. Okay, so any type of animation we can create here. Okay, so here you can see sheet metal .ipt, sheet metal millimeter.ipt. So this is inches. Okay, din is inches, is millimeters. So again standard din.ipt, standard for ipt. Okay, so now in your academical sessions we don't have any sheet modeling. Okay, so everything is on a part modeling. So first we will be selecting standard ipt. Okay, just click on standard ipt and just create, click on create. Okay, so it will take you to a 3D platform. Okay, so it takes some amount of time to load. Okay, so this is your 3D platform. Okay, so here anyway you cannot see the planes here. So why? Because first you need to click on sketch. See, if you click on sketch, you will get planes. See, and whenever we are drawing a 3D model, so 3D means three dimensional. Three dimensional means you have three coordinates, three planes, right? So that is x plane, y plane, z plane, right? So we have three planes here. Okay, so in your 2D and all, we were only creating a part model in two planes, that was your x and y. Here also your z will come into picture now. Done. So what happens here is, I need to create a part in such a manner that I need to, so for example, x plane is your horizontal plane, right? So y plane is your vertical plane. Okay, so if you select y plane, okay, so and if you finish off the sketch, the complete model will be standing vertical. Done. So normally if you just observe the body of the screw jack, it is vertically stopped, right? It is staying vertically, right? So means what? You select x plane? No, right? If you create explain and if you draw there, right, when you finish off the drawing, the model will be lying on horizontal plane, means the body will be lying like horizontally. Okay, so instead of going for explain, if I choose y plane, the complete model will be standing vertically, right? So it is better to choose y plane while drawing every part in screw jack. And in screw jack, for every part we use a revolve command. Okay, we'll revolve everything because everything is in cylindrical shape. We revolve everything. Okay, so just observe here. Okay, I need first we will go with the same order here. Okay, the same order as in your manual. So you have 1 as body, so 2 is your nut, 3 is your screw spindle, 4 is your cup, 5 is your washer special, 6 is the CSK screw, 7 is the Tommy bar. Okay, so I will go with the same hierarchy. Okay, so first one I will be creating body. So first if you want to create a 3D, first you need to draw it in 2D, then you can extend it in 3D, right? So first I need to go for starting the sketch. Click on that sketch. So obviously I will be drawing 2D sketch. Yes, okay, I will select start 2D sketch. See, now you can see 3 planes getting highlighted, right? Yes, you can see 3 planes getting highlighted. See, this is your XZ plane, this is your YZ plane, and this is your XY plane. Done. Anyway, if you select even the XY plane and or YZ plane, it doesn't make any difference because it is a revolving optional soft model, right? So what I'll do is I'll select XY plane. Okay, I'll select XY plane. So yeah, now my 3D platform is changed to a 2D view. Okay, and I want everyone to follow the same procedure. Okay, yes, everyone is doing with me that. Okay, done. Yes, okay. Now no need for dimensioning and all. Okay, you just see the body layout. Okay, you just create in the same manner, in the same shape. Don't worry about the dimensions. Okay, see what I'll do is I'll take a line command. Okay, so I will start from here base. Oh, okay, the structure is somewhat like this. Shape, I'm just drawing the shape of it. See, as soon as the model is closed, your command will be getting exited automatically. Somewhat I have written the shape, right? It is some sort of shape like this, right? But it is not according to the dimension. If I just go on giving the dimensions now, it will automatically go to this same shape, right? So see what happens here is these two are parallel lines, so I need to constrain the lines. So here you can see constraints, here you can see a parallel constraint. Click on that parallel constraint. Okay, I'll select these two lines. These two lines becomes parallel to each other. See, and you can see a command also telling that the lines are parallelly constrained. Done. So now I'll go for dimensions, or you can directly type D, shortcut in the D in the keyboard. Okay, so now okay, so what is this length? What is this length? It is 20 mm. See, as soon as I give that 20 mm, every line, okay, every line with respect to this dimension will be getting oriented properly. Okay, it will automatically change with respect to this dimension. Done. So next, okay, so after that, okay, so I will draw another line here, right? I will draw another line. Okay, so this line is my axis line, right? This is the axis line. So I will select that line and I will make it as axis. You can see a center line here, Okay, here in the format, if you just click on that line, select the line, okay, and select center line. See, as soon as you change the property of the line, the format of the line itself is changed, right? So what is the format for your center line? It is a long dash, short dash, long dash, short dash. So as soon as you change the line will be getting changed to a center line. Done. So now what I'll do is I'll go for dimensions. Okay, start giving dimensions here. See, if I start selecting these two lines, it will not take the dimension in radius. Instead, it will take the dimension in diameter, because I have defined that line as center. So any dimension taking from the center will be twice of it. So if you are writing a radius, means it will be a diameter, right? So it will give you the diameter there. Okay, what is that diameter? See your manual, it is 100. Yes, so from here to here it is 140, right? And length of this line is 3 mm. Okay, so and length of this line is 40. Okay, and the distance between these two lines, this is 10 mm, and distance from this point to this axis is 100, and distance from this line to this axis is 50. Distance from this line to this axis is 70, and total length distance is 185. Okay, and okay, wait. So I also need to give this dimension here. Dimension. So distance from this point to the axis, it is 66. And see that whenever you are giving the dimensions, the color of the line is getting changed. Okay, so green color indicates that the line is unconstrained line. Okay, you cannot finish a model without the converting the line to blue color. Blue color means you need to constrain that line. Constraining means you need to fix that line in all respective view, right? See, for example, now you can change the dimension of green, but you cannot change the dimension of blue, because green is unconstrained line, blue is constrained line, right? So now see, as soon as I start giving the dimensions, everything is in blue. Okay, so first I need to make it blue. First I'll select these these two lines. Now I'll give it as 185. Okay, done. Yes, still you can see some green lines. Yes, so I need to make it fix. How to make it fix? I need to make this line coincident with this point, right? Because that line has to be in the center. So what I'll do is I'll go for constraint. You can see coincident constraint. Select that, select the line, okay, and select the point. See, now everything will be in blue color. Yes, everything is in blue color means the complete sketch is in constrained manner. Now I can finish the sketch. Okay, see, this is what I have written is the sectional view, right? If you revolve this to 360-degree, it will be becoming a body. Yes, right? And I have also given the axis. So what I'll do, I'll go for finish. Okay, I'll go for directly revolve command. Since there is only one profile, automatically it will be taken there. If you have more than one profile, then you have to manually select there, and you need to manually select the center. Since in my drawing I had only one center and one profile, the body is created there. Okay, if you want 360-degree of body, you can just go and select OK, right? Otherwise, if you want a half section, right, or right half section means I want a 270 degree, right, or a half section means I need to produce it for 180 degree, right. Anyway, I don't want a section here, I want the complete model, I want it to 3D, completely constrain it to fully, so I'll select OK. So this is your body, right. But if you observe properly, you have a fillet here. Yes, you have a fillet here. Now you can also rotate this. How to rotate this means hold your scroll button and hold the shift button. You can pan it. Anyway, my mouse is not properly working. Okay, so hold the shift button. See, you can rotate it. This option we call it as orbit. Otherwise, you can also go for an orbit option in the navigation bar. This is the navigation cube. This is the navigation bar. So here you have a orbit. See, if you select, and you can revolve it, you can revolute it, you can do whatever you want, right. You can fix the drawing to whichever view you are flexible with. Done. So now I want a fillet here, Allah. So just go to fillet here. You can see a fillet, right. So click on the fillet, right. So this fillet is of radius 8, so type 8 here. Okay, so just select on this part, sorry, not that one. So go for fillet 8, so select on this one. See, you can see a preview. Yes, done. So again I want a fillet here also. See, if you observe here in this edge, here in this edge you have a fillet, you want a fillet there also. So just click to add another fillet. Okay, so give a dimension of, okay, what is that fillet? Anyway, if you see in bill of material, in description, if you see in bill of material, in descriptions he has given that unless otherwise stated. Can you see that? Unless otherwise stated. In bill of material, go to descriptions, there he has written unless otherwise stated. Means what? If you see any fillet or chamfer and he has not mentioned the dimensions, what is the standard you need to take? If it is a fillet means radii 1 mm. If it is a chamfer means radii, angle, length of 1 mm, angle 45 degree, 1 into 45. Okay, so he has not specified here the fillet, so I will go for 1 here. Okay, and I'll select that fillet. Can you see a fillet here? Done. So if it is okay, just select on OK. See, your body part is finished. In the screw jack, the body is finished. Means I have finished part 1, but yet it is not, I have not applied the materials now, right? Why? Because see, he has given the material as cast iron. What is the color of cast iron? It will be somewhat dark in color. Normally carbon content is more, it will be in black color, right? So I need to set some materials here. So how to set the materials? Here you can see application menu I, right? So next to that you have a small arrow mark. Click on that. It will take you to I properties. Go to I properties. Here go to physical. Go to physical. Here you can change the material to whichever material you want. Okay, by software itself, it has covered nearly all types of materials which is used in the overall world. Whatever types of material you want, every material is here, is there. So you want cast iron, right? So if you go for cast iron cast, so just type I, see, it will automatically take you to iron. So next is, you have different types of iron there, gray iron, ductile iron, malleable iron, right? I want cast iron. Click on iron cast. As soon as you change it, every mass, area, volume, everything is automatically taken there. Okay, so just click on OK. See, the color changes to a realistic view, so somewhat into an cast iron. Done. So after this, okay, you have done the part, right? You need to save it. So what you need to do is, you need to go here, click on save as. As soon as you click on save as, it will automatically take you to the respective folder where you have created the project. Yes, if you have created the project properly, it will take you to the screwjack folder. Okay, so here and here I request, see, don't save any of the file or don't keep any of the file inside this old version. Okay, that that file, it actually stores your files as a backup. If you store any file over there, you cannot open it, just like your Tirupati hundi. Okay, you can store there, but you cannot retract it back. Okay, so once any file is stored inside, it acts as a backup. Okay, it acts as a backup. So here we have a cloud storage facility. Okay, so your files will be automatically getting stored in the cloud if the internet is connected. Okay, so that file will be taken from the old versions. So even if any of the file is lost, you can retract it from old versions. But anyway, in your PC it cannot be done, so don't save anything in old versions. Okay, so here, so see that the type should be .ipt. Normally if you open the file by metric in millimeters in .ipt, automatically it will be taken to .ipt. Okay, don't change that, let it be in .ipt. Okay, file name you change it to body. Okay, type as body. Okay, and just click on save. Okay, so the part model will be getting saved. So we have created one model successfully. That's it. After saving it, just close it. Don't keep it there. Okay, why? Because it consumes more amount of RAM memory. Okay, and if you go on just minimizing that, so if you minimize means what happens, parallelly the RAM will be utilizing some memory for body and again for the next parts. Okay, and your system doesn't have that much amount of configuration, and future or further as you go on for assembly, the system may get hanged. Okay, or your complete assembly may be lost. Okay, so that's why as soon as you create a model, complete it. Okay, close it, save it, close it. Don't keep it or minimize it over there. Done. Okay. Okay, so the second part is nut part. Okay, so I will go for nut. So the same procedure, just observe here, go to new, same, I'll select standard MMIPT, click on create. Yes, the same window opens, right? So go for sketch, select the plane, right? So until and unless finishing for the complete parts of your screw jack, okay, I will be selecting XY plane because all are vertically mounted, right? That's it. So select XY plane. Okay, so the same procedure, first draw a random shape. So how it is, yeah, see, while drawing axis line, you need to make it blue in color. Means what? I am constraining the axis line itself. So if I just start my dimensions with respect to axis line, which is already constrained, the parts which is dimensioning with respect to that will be getting constrained. So now I'll select that line. So select on center line. Done. So just go on giving dimensions from here to here. The distance is not 50, it is 38. It is given in the top view, that is 38. Okay, so you can see that below that, right? So there is a front view as well as a top view. This dimension is given in the top view. So distance from here to here, it is 50, right? And the total height is 45. This distance is 10. Again from here to here, so from this one is 10. So this is also 10. See, if your lines are not constrained, you can manually move it to anywhere you want. Means what? If it is in blue in color, see, I cannot move it. Means it is already constrained. So if it is in green color, you can move it. It should not happen like that. Wait. Okay. So again, distance from. Okay. See here, you have a. This is not a straight one. You have a conical shape. So go to arc. Okay. Select. Okay. Before deleting that, I will draw an arc, center arc. Keeping this point as center, I'll draw an arc. So already it is 10 means I will get an arc. Okay, so now go to dimensions, click on the center. Okay, don't go for this one. Can you see an option next to the cursor, a small white color line? Just observe what happens if I move here. See what if I want a tangent? See, it changes. Can you see that? See that white color part next to the cursor, it is getting changed. See, this is the distance from the center, this is distance from the tangent. I want distance from the tangent, so tangent distance is from the axis line to the tangent, it is how much? 90. Okay, so anyway, I need to make this as 5. Okay, 5. Then we'll draw a line here. Okay, so we'll make this point coincide. So what is the distance from the center? So from here to here it is 5. Again from here to this point it should be 0. Sorry, from this point to this axis it should be this is 10, this is 10. Okay, so from here to the center it is, let us constrain it, so this is 5. Okay, and I need to make this coincide, so select this line, select this point, make it coincide. This is 45, this is 10. This is 5. This should be 90. Done. So this is 90, this is 50, this is 38, 45, 10, 10. So I think I have given the proper dimensions there. ಕಡಿಮೆ ಆಯ್ತಲ್ಲ. 50, this is 38. this is 90, 10, 10, 45. Okay, we'll see that. So go to revolve, done. Yeah. So this is your cup. Okay. I mean, sorry, the nut. So go to properties, change the physical, change it to, okay, here he has given a gunmetal. So if you just click on gunmetal, you won't find a gunmetal. Okay. So if you want a gunmetal, so normally gunmetal is an alloy of copper or alloy of brass. So normally we go for brass, sorry, okay. So go for copper alloy, so it will take you to the color of the copper alloy. Okay. So I think you have a fillet also there. Yeah, you have a fillet. So go to fillet, so enter the radius as 5, so select the edge, so it is 5. So this is your nut. So after that, the same old procedure, go to save as, change it as nut, save it. It is done. Okay. So now I will show you the next part, that is your screw spindle. Okay. So the same old procedure. So go to new, select standard MMIPT. So the same old dialog box opens. Okay. So the same drawing window, so go to sketch. Okay. So now, since we are always selecting XY plane for our all the parts of our screw jacks, here also I will be selecting XY plane. Okay. So I'll just draw the spindle now. See, just remember that I am drawing half of your spindle here. Okay. So if you do half of the spindle, you can revolve it. It is cylindrical in shape, right? So I will start from the center. Okay. So previously in your body as well as nut, it was a hollow cylinder type, right? So that's why I started with some eccentric of axis, right? I started with a distance of some length from the axis, but here this is a solid part. This is not a hollow part. So means what? I will be starting from the center itself. See, that's it. So this is your outline for spindle. Yes. Anyway, don't worry about here. You have a chamfer here and here. You have a chamfer. Okay. So don't worry about that. So, but if you see the outline, it somewhat looks like a cylinder in this manner, right? Okay. So now I will make this line an axis. Okay. Done. So now just go on giving dimensions. Okay. So dimension. So what is the total length? Total length is 240. Yes. And what is the diameter length, thickness diameter of this? 38. 38, 38 here. Side view alli ನೋಡಿ. 38. So next. Okay. So next, what is this length? This is 13, right? 13, 13. So the diameter is 22 from here to here, and this diameter is 65. I want the length of it. So 83 from here to here, it is 83. Done. Yes. Is there any green color line over there? No. So everything is in blue, means it is completely constrained, right? Okay, so I have given everything, the length. Yeah, done. So go for finish, go for revolve. Done. Somewhat your spindle looks like this. Yes. So there are chamfer at the two ends of the spindle, at the head of the spindle. So go for chamfer here. You have a chamfer option. Okay. So now here, you know the length as well as angle, right? So this is, you have three types of chamfers. You have three types of chamfers. Okay. So one is, if you know the total distance of two edges, can you see here? This is the distance. So 2 millimeter means this side 2 millimeter, this side 2 millimeter. So I don't want that, because I know the length as well as angle. So that is the second one. See, I know the distance of the edge as well as I know the angle of the edge, right? So I'll select this face, select this face. Okay. So edge, this is the edge. What is the distance? Distance is 10 mm into 45. Angle is 45. Yes. Can you see over there? So in the same way, you select, just click on apply. Okay. Again you do the same on this side. Select this face, select this edge, same 45. Okay. Done. Done. Okay. So next, again, if you see here also you have a chamfer. So go for chamfer. So here you need to select this face and you enter the distance as 1 for this edge. 1 into 45. Okay. So select OK. Done. Yes. I'll repeat again. I'll repeat. Wait. Okay. Done. So now after that, you have a hole here. You have a hole here, right? Okay. So now, so what you need to do is go for sketch, select the sketch, or do one thing, go for hole. Directly go for hole. Okay. So here you have linear, from sketch, concentric, everything. Okay. So just go for concentric. Okay. Select this face. Okay. And concentric reference, you can select any one cylinder. So just to identify the center. Okay. So now what is the hole distance? So here you can see that. So hole distance is 35, diameter is 12, right? So it is a 12 and 35. So give the depth as 35, diameter as 12. Okay. So here you have two types of drill points. Okay. One is a flat, another one is angled. Okay. So normally we go for 180 degree, it is automatically taken 180 degree. So if it is, everything is done, so select OK. So you have a hole there. Okay. So anyway, in my systems I don't, I'm not getting the thread option. Okay. So oh yeah, I got a thread. Okay. So now here I want a thread, but I don't want complete full thread. Okay. It is a distance thread. So what I need to do is, here just remove that full length. Okay. So now just click here. So by default it is taken as 10 mm. Okay. So length is 10 mm. Means what? I have started a thread length for only 10 mm. What is the thread length you want? You want a thread length for 30 mm. So another 5 mm is left as space, gap. Can you see that? Okay. So this is 30. Go for specification. So it is M12 means metric thread. Go for isometric profile. M12 into 1. M12 into 1. M12 into, oh yeah, M12 into 1, right handed. Done. Select OK. So this is your M12 into 1 thread. Done. So after that, again you have thread on the shank part. Here you have the thread. So again go for thread. Okay. select this. So here also, okay, you have thread. You don't have the thread for the complete shank part. You have an offset of about 3 mm, right? You have the offset of about 3 mm. So start the length thread from here. Just click here, not on this end. Select, see the orientation of thread. See, if my cursor is nearer to this edge, it will start the thread from there. If my cursor is near this edge, it will start from here. Okay, so I'll select here and I'll go for offset. Instead of giving length, I will give the offset as 3 mm. Specifications. Okay, so 3 means how much? So 240 minus 86. 240 minus 86. 150. So you should get a 3 mm offset there. Okay, you are not getting an offset there. Yeah, yeah. Length is 154, right? Okay. Specification. Okay, first we'll select the face. Yeah. So you have a 3 mm offset here. Yes. Okay. So go for specification. Isometric profile. It is 38 into 7. Oh, means it is a trapezoidal thread. 38 into 7. Got it? So you have a 3 mm offset here. Can you see that? So select OK. Okay, so this is your spindle. So we have done everything, but only thing is here we have a hole there. Okay, so what you need to do is, see, I will select the center plane over there. I will draw a circle in the center plane and I will extrude it. I will remove the material. Okay, so just observe here. I'll go for sketch here. I'll open this origin tree. This is the browsing window. Here these are the modeling tree. Okay, see, if you just click on any plane, that respective plane will be getting highlighted. Okay, so I have selected XY plane, right? So again I will be selecting the same XY plane. Okay, so here I will draw a hole. I will draw a circle. Okay, so from the center, so what is the circle diameter? It is 12. Okay, so now give the dimensions. So distance of this one from the bottom face, this is 35. Done. So finish the sketch. Anyway, I have drawn it at the axis. No need to set at the axis. Go for extrude. Okay, so here I'll select symmetrical and I will just move this arrow mark. Okay, here this is material adding part. Okay, so here, so this will add the material, so this will remove the material. So I will click on this. Can you see a hole? That's it. Okay, so that's it. So this is your spindle part. Yeah, knurling. Okay, don't worry about the knurling. Okay, so anyway, we can't do the knurling in Inventor. Okay, so don't worry about that. So this is enough. So now just change the material. What is the material? Go to physical. Okay. Oh, anyway, I will go for that is steel alloy. Steel alloy. Steel alloy. Okay, we'll select a steel alloy. Okay, so Fe means iron, right? Iron alloy. So we can go for steel alloy, stainless steel alloy. Okay, so that is your spindle. So the same old procedure for saving it. Save as. So this is screw spindle. Done. Thank you. Okay, so I will go for the next part. So the next part is cup. Okay, so doing cup is very easy. Okay, again here this is not a solid part. Okay, so this is a hollow part. So again I will be starting from a distance of the axis, from the distance from the axis. Okay, so I'll go for new, same standard MMIPT. So go for sketch, same XY plane. Okay, so just draw a sketch. Done. See, done. So somewhat it looks like this, right? If you see the cross section there in the manual, it looks like this. Yes, done. Okay, so now I'll select this line. Okay, I'll make it center, axis line, center line. Done. Okay, so now go for dimensions. Okay, so now tell me the dimensions. So this line is 12. No, it is 12. It is 12. So diameter is 22.5. Distance from the center is 22.5. Distance of this point from the center is 45. And distance of this point from the axis is 65. So which you can see in the top view. Distance of this point from the axis is 38. Distance between these two lines is 5. Total distance is, what is the total distance? 42. Anyway, it will not take it. Why it is not taking that? Okay, so we'll delete this 65 first. Okay, so from here to here it is 42. Go for coincident, select this line, select this point, make it coincide. Yes, okay, which is okay, this is 6, sorry, this is 6, this is 6 mm. Done. Yeah, thank you. So this will be automatically taken to 68. Anyway, okay, so leave it. So this is your basic sketching of the cup part. Done up to here. So now I will go for finishing the sketch. Okay, so now I will go for revolve. Automatically it will take the revolving. So now if you see that there is a hole, yes, so now here, okay, so here in the cup part we need to remove some part here. Okay, so how to do that? So again go for sketch, open the origin, select XY plane. Okay, select XY plane, go for circle. From this point draw a circle of diameter or radius 5 means diameter 10. Okay, so just finish the sketch, go to extrude. Okay, just remove it. Okay, or you can just go for cut part and just drag the arrow mark. Okay, so now you have got you have removed the material at only one part of the circumference of your cup part, right? So now you want that type of feature on all the other end, or you want 4 numbers, right? You want that features to be repeated 4 with an angle of 90 degree. So for that we use an option called as circular array. Okay, these are called as circular array or circular pattern, the same type which you were utilizing in AutoCAD. Okay, so I'll select circular pattern. Now it is asking which feature you want to pattern. So I will select this feature. Which is the rotation axis? I'll select any one axis. How many numbers you want? I want 4. So automatically it will be divided into 360. So 360 divided by 4 means automatically it will go to 90 degree. So now just select OK. Done. So after that go to Y properties, go to physical. What is the material? So material is cast steel. Okay, so go to steel and cast. You have steel cast, select OK. Done. So after that, same procedure, go to save as. So just type cup, save. Done. So that is how we create the cup of a spindle screw. Cup of the screw jack. Thank you. Okay, so next part is washer special, which is the easiest part. Okay, so just open the new. Okay, so just go to standard MMIPT. Okay, so go to start, same XY plane. Okay, so here, so just go for line. Okay, so just draw the cross section. Make it center line. Okay, so just give the dimensions. So the diameter is 14.5, distance from here to here is 14.5, angle is 45 degree, distance from here to here it is 25, distance from here to here is 8, total diameter is 35, total diameter is 35. Go to coincident, make this line coincide with this point. Done. So after that, if this is done, so the distance from the ID distance is 14.5 diameter, angle of that chamfer part is 45 degree. Okay, so distance from this point to the axis is 25 in diameter, thickness of that washer is 8, total OD of the washer is 35. So if it is done, go for finish, go to revolve, go to revolve, so go to OK. Okay, so now just there is a fillet here. Okay, so go to fillet, so make it 1 mm. So just do the fillet at this part, select OK. So go to change the properties to physical. So the property of the washer special is same, steel alloy. Okay, so after that just go to save as. So this is washer special. Okay, thank you. Okay, so the next part is CSK screw. So I will go for the same procedure. So selecting the same plane, XY plane. Okay, so this is a solid one, this is not a hollow part, so I will start from the center itself. Okay, so this is the screw part, so I'll make it as an axis. So after that, go for diameter. So the diameter is 12, total length is 30. Okay, so the angle is from here to here it is 45, distance from here to the center is 24. Okay, so finish it, go to revolve. So this is the CSK screw, so there is a chamfer, go to chamfer, select the second one, distance is 1 mm, select the face, select the edge, so you have got a chamfer. So after that, go to sketch, select the XY plane. You need to draw a square. So go to line. So distance from here, it is 2 mm, means here it is 1 mm. 1 mm. Depth is depth is 3 mm. Depth is 3 mm. So here again 2 mm. 1 mm. So next tab angle 90, tab 3 mm. So this side tab 90, tab 2 mm. So again here tab 90, tab 3 mm. So we'll close it here. So finish the sketch, go to extrude. So just remove it, symmetry, remove the material. Done. So next is thread part. So go to thread. So it is not full length. So length is 30 minus 9. 30 minus 9 is 21. So you have 3 mm offset here. Okay. So this is your CSK screw. Go to materials. Go to physical. Change it to steel alloy. So this is the CSK screw. So just go to save as CSK screw. Done. Okay. So the next part is the last part. So that is Tommy bar. It is quite easy. Okay. So the same procedure. So go for sketch. Here also I'll select XY plane. So I will just write the layout of it, the half layout of it, half section of it. Okay. So now we'll select the line, make it axis. So now go to the diameter. So the diameter is 12. Diameter is 12. So the angle from here to here, it should be 45. And this length is, this diameter is 20. Okay. So now the total length is 275. From here to here, it is 275. This length is constrained for 62. 62. Okay. So now go for arc. So from here you draw an arc. Okay. So just go to extend this line. Finished. So now just remove this line, go for finish, go to revolve. Finished. So this is the Tommy bar and the material is same. Go to eye properties. Okay. So the material is steel alloy. Steel alloy. Done. Okay. So don't worry about the knurling part and all. Okay. So you have a chamfer here. So you have a chamfer. So go to chamfer. Okay. So select the face, select the edge, enter a thick distance as 1 mm. So that's it. So this is your chamfer. Okay. So just go to save, select save as. So this is your Tommy bar. Okay. Yeah. Okay. So the next part is the main part where we have created many individual 7 parts, right? Now I need to assemble all, okay, into a single part, single working assembled part. Okay, so here I will go for new. Okay, so same metric. Here I will not select standard IPT because this one was used for creating the part model. Now I need to go for assembly part. So for assembly I will go for standard IAM. IAM is the extension, is the metric unit where I am using in millimeters. Okay, so .IAM is the extension for assembly. .IPT is the extension for part model. Okay, so I need to select standard IAM. I'll go for create. Okay, so here first I will go with the same order as of your bill of material. Okay, so the first one is body. Okay, so I'll go for place. Just I'll go for place. Okay, I'll select the body and I'll open it and I'll place it here. Okay, so just right click. Okay, okay, so now here this is the base of your screw jack, right? So here I need to fix this part, okay, because with respect to this part I will be assembling other parts. So this part need to be fixed at one place, right? So otherwise if I go on assembling other parts, the main part will be moving with respect to the parts. Okay, so I need to fix one base just like a foundation. Okay, I need to fix it at one place. So what I'll do is I'll right click that part and I'll make it grounded. I'll make it grounded. Okay, right? So now it is fixed. So now it will not move from anywhere. Okay, so the next part is what? So next part is your nut part. So go to place. Okay, select the nut part and place it here. Done. Done. So now how to assemble this? So here uh, this one constraint part. Okay, I use normally the constraint part. Okay, you can also use joint part. So here in joint it will also show you the animation, but I don't want animation here, I want the constraint part. So what I do is there are some degrees of freedom. I think you know what is degrees of freedom, right? Okay, so I will be just going on matching the degrees of freedom. Okay, so for example if you take here, this axis should be coincident with this axis, right? And can you see this face here? That face has to come and sit here, right? But it can rotate there, but it should not move from there, right? It can rotate with the same axis, but it should not oscillate there. So I need to fix it. So I will go for constraint. Okay, so now I will select this. Is you have different types of constraints here. You have mate, okay, you have angle, you have tangent, you have insert, you have symmetry. So okay, I will go for mate. I will select this axis and I will select this axis. See, I mated the axis, means see what has happened. This part can move on that axis to anywhere it want. Yes, it can also rotate, right? So but now what I need to do is I should make sure that it should not oscillate like this, but it can rotate, right? So how to do that? I'll go for mate again. Okay, I'll select this face now. Okay, go for constraint, go for constraint. Okay, I'll select this face. Can you see that face as well as the arrow mark? I'll select this face and I will mate that face with respect to this face. Can you see that? See now what happens? I will select apply. Okay, so now see, now it is rotating. It is rotating, but it is not oscillating, right? It is rotating it in its own axis. This axis is coincident with this axis, but it is not oscillating because I have mated the surface, right? Next, above this will come your spindle, right? Screw spindle. So first I will go for placing that. So select your screw spindle. Okay, so just click here. Done. Now here also this can rotate here in this axis, but as well as it can also oscillate, right? But here, okay, for time being I will not make it oscillate, I will make it rotate. Okay, So instead what I will do is I will fix that oscillation moment. Okay, so what I'll do is I'll go for constraint. So the same method, select the center axis, select this axis, okay, make it coincident, select apply. So then select this face, okay, and select this face, mate it. Can you see that? Done. So after that, above the screw spindle, above the screw spindle comes your cup, right? So I need to place it. So go to place, so select your cup, open it, place it here. Okay, so the same method, so go to mate, select the axis, select the axis, select the axis here, mate it, apply. Okay, so go for, sorry, go for constraint. Here also it can also, it can rotate, but it should not move above the spindle. So select this face and select this face. Okay, done. Now here I need to insert a washer. Above that I need to insert a screw. So go for placing it, go for place, go for washer. Okay, so now same method. So go to constraint, constrain the axis first, constrain the axis. Okay, so now just go to mating the surface, select the surface, select the surface, mate it. Done. So now I need to insert a screw, means I need to lock the top part, I mean the cup part. Go to place, so go to screw, open it. Okay, go to constraint, select axis, again constrain the axis parts, apply. So here I need to mate it back. So for time being I'll move it, right? So now go to constraint, select that face, mate that face with here. Sorry, go to constraint. Okay, so select this face, mate that face with respect to this face. Done. So select apply. So next part, last part is Tommy. So go to base, placing that, go select your Tommy bar. Okay, so now same, go to constraint, select the axis, select this axis, mate it. Next, here what I need to do is see that this face should be tangent to this face. So go to constraint. Okay, select tangent, select this face, make it tangent here. Okay, and here this is outside, this is inside. Now it is in the outside. If I click inside, it will come inside. So just click on OK. So this is your complete assembly of your screw jack. Okay, so that is your complete assembly of your screw jack. Done.